In this video, let us continue to solve problems based on arithmetic progressions. And the question is like this: in which of the following situations the sequence formed will form an AP? So that is nothing but an arithmetic progression. So we've got one of the situations here, one of the situations here, which says the number of students left in the school auditorium from the total strength of 1,000 students when they leave the auditorium in batches of 25. So now we have the total number of students. Total number of students is 1,000. So when they leave, the first batch, what happens when the 1,000, when they leave in batches of 25, you subtract 25 from 1,000. So that's the first thing, right? You've got only 975 of them left. And then again from 975, another 25 will leave. So that will leave you with 950. Now again from 950, 25 will leave. That will leave you with 925. Now from 925, 25 will leave. So that will make it 900. So the sequence is like this, first you've got 1,000, and then it comes to 975, and then it becomes 950, and then it becomes 925, and then it becomes 900, and then so on. It gets on decreasing by 25 only. So that's the constant, right? So that's the important thing. So we've got A as 1,000 here, and then we've got the common difference, that is D, as minus 25. Most importantly, remember, you need to subtract A2 minus A1. It's not A1 minus A2. So everything, when you subtract 950 minus 975, 925 minus 950, you get the common difference as a negative 25. That's a constant. So as long as you've got this, this D is a constant throughout, then the given situation definitely is in arithmetic progression. The students are leaving such that, at the end of it, when you see the sequence in which they've left, that definitely is an arithmetic progression. So this situation formed, the sequence that is formed as a result of this situation will definitely form an arithmetic progression. Let us quickly look at another situation and see, if that is also going to form an arithmetic progression or not. So we've got another situation here, which is like this. The amount of money in the account every year when rupees 100 are deposited annually to accumulate at compound interest at 4% per annum. I'm not sure if we've already done interest in principal and all those things. There are two kinds of interest, simple interest and compound interest. So here we're going to talk about compound interest. So now let's not get into detail about the compound interest part, but let's just, worry about if this is going to form an AP or not. Of course, it's going to depend on the compound interest, but, let's just check it out on the surface. So the thing is, we know that, if P is the principal, and R is the rate of interest per annum, if R is the rate of interest per annum, compounded annually, that's important, compounded annually, then the amount AN at the end of n years. At the end of n years, the amount, that is AN, that is going to be given by this AN equals principal times 1 plus R divided by 100 to the power n. So this is how you calculate the total amount at the end of how many ever years, compounded annually, So let's see, let us try and compound it. What is given here is it's the rate of interest is 4% per annum. And time, we can just go on. Let's see if it forms an arithmetic progression. We can stop at a point. So now, here we've got P as equal to rupees 100 because that's the principal, right? That's how much you're depositing. And then R we've got is 4% per annum. So what we're going to get when we start solving this is AN, we don't know how many years. We're going to get 100 times 1 plus 4 by 100 to the power n. So this is nothing but 100 times, taking LCM and all, we're going to get 104 divided by 100 to the power n, which is 100 times 104 divided by 100 is 1.04 to the power of n. So now let's say for, let's try it out for 3 years. For 3 years, so what's it going to be? So say A1, the first year is going to be 100 into 1.04 to the power 1. And then the second year, it's going to be 100 into 1.04 to the power 2. Then the third year, it's going to be 100 into 1.04 to the power 3. So let's first check this out. So what we're going to get, now let me solve it here. A1 is going to be 100 times 1.04 is exactly 104. And A2 is going to be 108.16. And A3 is going to be 112.48 and so on. So the series is like this. Alright, it's like this: 104, 108.16, 112.48. I've got this by solving these. You square this and multiply by 100. Cube this and multiply by 100. You get these. Now these definitely aren't an AP because the difference is not constant. 108.16 minus 104 is 4.16 is the difference for this. And then for this, you're getting, differently. It should be 4.32, I guess, if I'm not wrong. Something like this. So there is the difference. These are not equal. So the D is not equal. So therefore, the given sequence, the given situation is not going to help you form an AP at all. So this situation is not going to give you a sequence that is going to form an arithmetic progression. So therefore, this is not AP. This is not in arithmetic progression. So that's what we found out by solving this situation. So that's it then. So I'll see you in the forthcoming video. This ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on arithmetic progressions.